Okay, welcome everybody. Thanks, Sean and Organics for the invitation and all to do the presentation here. Just before I get into my own slides, just looking at the screen at the moment, world global population. By the end of this week, I think we're going about to over 200,000 a day increase. So we have a couple of days yet to go. But by the end of this week, this year, on this planet, we're going to have 8 billion people to feed. Right, so as scientists and researchers and producers, this is the bottom line. This is what we have to do. Look after that population. Right, so going forward, and on top of all that, we have to look after the environment. So we really need to be careful about how we move forward. I'm based at the Walsh campus there in the Southeast Technological University, and I'm involved in the Masters in Biological and Agriculture, Organic Agriculture, Livestock Management, Soil Health, Water Management, Irrigation and Wetland Systems. And while they're individual headings, they're all integrated. We can't have one without the other, and it's all part of where we live, the effect we have on our environment, the effect we have on everybody and everything around us, and we really have to move forward very carefully. And up to now, in agriculture, in industry, that hasn't happened at all. We've been very careless, and at some point, we're going to pay for that. Okay. So we have to start looking at the bigger picture and look at the effect we're having overall, globally and locally. And everything has to, we go back for centuries, a lot of centuries. The whole system has evolved before humans were able to interfere or interact. We had a whole biosphere there where everything worked very well. And then coming back and having a little bit more focus on the ecology of what's around us, we have a wonderful system. There's an awful lot of natural systems there that have evolved again over centuries that work extremely well. And when we look in and see where we can fit in and play our role and just move along with the system without disrupting it, without destroying it. And if we look a little bit closer at our ecology, our local areas, there's an awful lot that's there that we don't see until we pay a little bit more attention to it. But the problem is, if we don't see it, we don't take care of it either. We ignore it, and I'll be looking mainly at ruminants, ruminant livestock, dairy production here today, and even ruminants, they have a part in all this as well. And they have played a part for an awful lot of centuries, again, before we started to farm them and manage them, and then skew the whole system a little bit to our advantage. So if we look at ruminants, we need to look a little bit deeper at what we have and what we're trying to manage. Okay, we have ruminant livestock management, so that's an area I'm involved in quite a lot in the college or in the university. But if we look at rumen livestock management, it's not just the animal, it's what goes on inside the animal. right? So when you think about rumen as opposed to ruminant livestock management, this is what we're managing. Not just that big animal that you see out in the field and you move from one paddock to the next, to the next, to the next every day. You know, it's what's happening inside in that rumen. You know, we've got billions of microbes in there. And just as an example, the first screen we had today was our global population hitting 8 billion people, possibly by the end of this week. Each drop of that rumen fluid has 10 billion microbes. Every single drop, right? That's what we're managing when you talk about rumen nutrition. So try to picture not just the cow, but what's happening behind, what's happening at microbial level, because that's what we're managing. And it's how we manage that. That's where the inefficiency or the efficiency comes from overall. So again, if we fit the cow into that ecology picture, and again, we look at the cow in the field, whatever, and we think this is what we're managing. But there's a lot more to it than that. So we have all these microbes that we have to look after, and they're in a very fragile environment in there in that room, and they all have their own place. You know, the top layers, you have a higher pH, the bottom layers, you have a lower pH. So there's a massive system, a very complicated system in there that we need to take care of and not to disrupt. But it's not only in the rumen. We've got similar activity in the soil, right? So everything underneath that we don't see physically, but because we don't see it, that doesn't mean we don't have to manage it, and manage it very, very, very carefully. Every time we disrupt that population down there, we're disrupting the potential for the plants on top to lift up nutrient. If they can't lift that full profile of nutrient, then the nutritional profile of those plants is not good enough for that other group in there in the rumen. So we can't look at any part of the ecosystem separately as a separate entity. It's all combined, it's all together, you know, and it's understanding what are the links between the soil, the plants, the animal, and the livestock in there in that rumen. Right, so it's how all of that is managed and how it all comes together and how to get the best performance from it without disrupting it at any point. And remember, we're talking about microbes here. So any kind of an artificial or a non-natural element going in there is going to disrupt that, whether it's in the soil or in the rumen, right? Because it's not part of the natural system. Okay, I'm just going to use this herd, and thanks to the herd owner, Anthony, for letting me put this up. This herd in the Ann Valley in Dunhill, and they're the background pictures I showed you as well. It's a very unique area. Farmers have taken a totally different approach down there. But the result of taking that approach is animal health, animal welfare, animal longevity, animal performance. If you look at the animal here, look at the date of birth, October 2008, and we have lactation 1. Lactation 3 was her breast lactation. She's just finishing lactation 10 at the moment, right? Over her lifetime, she's averaged 8,490, just short of 8,500 litres per year over that 10 lactations. You know, on a 305-day lactation, she's 7,700. That's phenomenal performance for an animal, you know, but the main reason for that is because everything that animal is eating, putting into that rumen, has been very carefully managed. And then the animals are very well managed on top of that. And that's just a snap of the herd. It's not a big herd. We have 50 cows, 62 livestock units, a small number of followers, 12 calves. Last year's production, 399,000 litres, just a little bit short of 400,000 litres. That's 7,980 litres per cow. Average lactation number, 6. Right, that's good management. And the bottom line, milk margin over feed at 0.27 or 27 cents a litre after feed. So that's a very well managed herd. High number of lactations, low feed input. That production is achieved with just on 600 kilos of concentrate per cow. Okay, how can we get that kind of production? Very simple. I don't want to get into chemistry or anything here, but I said I'd put this one in just as an explanatory one. We're not over, I'll go back one slide. Right, if you look down the very bottom, winter dietary protein, 15.5%. Overall, every day, we try never to go over 16% total protein in the diet. Right, so even when the animals are outside in summertime, they get a very small amount of concentrate and roughage, either hay or silage. They'll always have access to that going into the parlour or coming out of the parlour. No one of the ground gets chemical nitrogen or manufactured nitrogen. We use different plant species. We've been using clovers for over 25 years now in the sward, working really well, so there isn't a requirement for any kind of manufactured fertilizer, in particular nitrogen fertilizer. And by doing that, we haven't been loading in high volumes of nitrate or nitrogen into the rumen. So those ruminants, those rumen livestock, if you like, right, they're not being destroyed with chemicals going in. It's all natural product. The grass mixtures we have are producing the nitrogen in the soil. They're producing the sugars to feed the soil bacteria. The soil microbes are feeding the plants back minerals, and that mineral is fed into the rumen livestock, the rumen microbes. And the system works very well because we've taken out the chemicals, we've taken out the manufactured fertilizers, and we've let nature do the work for us. And people generally have a concept that going towards organic or low input systems, you're going to lose production. But it is a stepwise process. You're not going to be able to go from a high input system to a zero input system overnight. That is a big shock to the system, but if you take a couple of steps, say over 2 years, 3 years, take a third of the farm this year, right, you're going to change over your system there, put in your new seeds, your new plants, and let them work. And then the second year, take the next section, and the third year, take the next section. And the biggest surprise people have, I suppose, is how quickly the soil microbes adapt and how quickly the new plants adapt. And you get the performance, provided you don't go back in there with the concept that, well, if I put a little bit of manufactured nitrogen on that, it'll help it along. It won't. It'll have the exact opposite effect, and I'll try to demonstrate that. But getting this urea out of the system is going to make a massive, massive improvement within the rumen. And When we look at maybe trying to adjust the production on the farm, on the ground, we pay a lot of attention to that. But we don't pay enough attention to the inefficiency of overloading the rumen with too much nitrogen or too much protein. We're losing anything up to 35% of our production capacity by doing that. That's why we insist never going above a total 16% protein diet going into those ruminants. Here's a snapshot of the farm. And just to look at this slide, up on the top left corner there, you'll see clovers, white clovers. We've been using essentially our McGill Turbo Mix for about 25 years now. It's got a nice blend of grasses and legumes in there, the red and white clover, not an awful lot of white, or reds, mostly whites. It had some ryegrasses in there. There's timothies and fescues, and they're the ones mainly that we've been concentrating on and keeping an eye on, and even depending on for quite a number of years now. Because once we pulled the nitrogen out of this farm quite a number of years back, we discovered that in the winter time, this time of year right now, and going into early spring, those fescues and timothies just kept producing, they kept coming, unless we had a really severe frost. So they always gave us good winter cover. And then by the time we got to the end of March, April, May, and temperatures start coming up, and even right now today, we've got pretty high temperatures right now. The clovers are still coming. Even though we're late in the year, we're still getting really good cover for that. And you can see there on the bigger picture here on the left-hand side, down near the bottom, you can see there's quite a lot of clover in that sward. And again, people bring up this idea about you can't graze animals out on high clover swards. What about the bloat issue? And this myth comes up again and again and again and again. And we've seen over the last couple of years where animals have been lost because of bloat going out on these kind of swards. Why? Because people have come in and advised those same farmers to put chemical nitrogen out on those swards, which they do not need. In this farm, for the last 20 odd years, we've never experienced one case of bloat. Not a single one. Why? Because we've removed the chemical nitrogen completely. So they can graze those swards. We don't get that quick nitrate release. It gets through the rumen wall and into the bloodstream to cause nitrogen poisoning. Right? Once that happens, if you've got chemical fertilizer out there, you can induce that. That will disorientate the animal very quickly. Then they're not able to belch, get rid of that gas. That causes bloat, and the animal dies. But it's not the bloat that's the cause of the death. It's nitrogen poisoning. And I think there's only recently been a realization or an admission of that. So moving on that sward, if we look at the right-hand side, or the second picture down on the left, these are mixed species that we've introduced over the last couple of years. They're working quite well, along with the grasses and legumes. Incidentally, on the clover swards that are those mixtures, after about 2 years, generally we lose the ryegrasses out because we're not feeding it with nitrogen. So we're dependent after that on timothies and fescues, and they are working really well for us. Right, so on the multi-species then, we've introduced herbs for a good number of years now. Some of the farms were zero grazing these. We finished this year zero grazing on one of the farms for 5 years. That was a 15 species mix, and again we had a little bit of ryegrass in there starting off. We lost it in year 3. The fescues haven't done that well. The Timothys do well in the winter time and early spring. Fescues are not quite as strong as that mix, but we've got 5 herbs, we've got 6 legumes. We've got some dandelion after creeping in there as well, naturally, which we're not worried about at all. But that's working extremely well. There's about 10 cuts taken off that every year with the zero grazer and fed directly into the animals. On the farm here as well, included in the rotation, we have maize. We do a 12-year rotation on the farm. So those clover swarts, we get 10 to 12 years out of those. And they just stay performing year on year on year on year. Management of that, we get slurry out about 4 or 5 times a year. I don't know if you're an old money or new money, but generally we don't put out any more than 1,000 gallons of slurry in any one application. Reason for that, again, we have to look after those soil microbes. You know, we've noticed again and again on farms, you'll see a farmer going out and you put 2,000 gallons of slurry per acre in one application. You know, go out an hour later, just walk up the track, the wheel track of that slurry tank, and count the number of dead earthworms per metre. It's absolutely phenomenal. That's what we see on the surface. But hopefully you understand the amount of microbes that are down underneath and the damage we're doing down there. The earthworms come to the surface and try and escape. The deep borers probably get away to get right down. But those microbes can't move. And we absolutely roast them out of existence with masses of slurry at any one application. Again, it's about management, soil management, rumen management. If you look at that bottom left-hand corner, we have the maize in. I left a little bit of it open. You see the soil just slightly disrupted after the maize crop. There's this year where the picture on the left where the animals are there. There's 2 different mixes in that field. The dairy farm is just in the trees in the background, and you can see the entrance into the farm right at the centre of the trees there. What we were hoping there is that the animals coming out would tell us which of those mixes they like best. So we're keeping an eye on them coming out, and they're totally indifferent. They weren't one bit helpful. You know, some of them will go left, some of them will go right. They grazed everything down very well. We didn't get any more residual on the left sward or the right sward. Very non-cooperative group. But that's their normal routine. They're very relaxed. They just go about their business and they don't care what's going on around. Okay, so we thought, okay, this year, on that area where we took off the maize this year, that's reseeded now. We took that maize off the Friday before the plough match. I think it was close on mid-September. And we had the new seed in there on Saturday, like Friday evening. It got the normal 1,000 gallons of slurry per acre. And he was in there with the seeder the next morning and put in the seed. But what he did, and this is the farmer's suggestion, right? Because he didn't get an answer from the cows as to what they like best, he thought, okay, fair enough. You like both of them. So he mixed 50-50, both of those mixtures. And that's what he put in that field where the maize is now. So that's what's coming through in that area for next year. It's nice and green right now. Got it in on time, it's doing very well. So there's grasses, legumes and herbs in that mix, and it's doing really, really well. That won't get any more fertilizer from now on, only just slurry. We're keeping an eye on the P's and K's as well. in the soil and the lime requirement, we're not tending to have to use very much lime. The pH is holding reasonably well. We're up around 6.7, 6.8 for a good number of years now, but we'll keep an eye on it. We think that's very likely because we're not putting out a lot of manufactured fertilizers on it and disrupting that pH there. Okay, where are we getting this information from? Or, what's the science in there? So this is our trial plots area down in Carriganure in Waterford at our campus down there. That's just a map of the trials area. It's right beside the bypass road. We got that in a few years back, and again, we took the same approach here. There's no manufactured fertilizers going out there for a good number of years, and we're monitoring the production, see what's happening there. We'll be keeping an eye on the pH, on the P status, the K status, but we're not just looking at the surface, or that top soil, the top layer of soil that we normally analyze, right? We're going in now, because these multi-species, potentially some of those like your plantains, sorrel, chicory, trefoil, all of those, yarrow, potentially they can get their roots down a full metre. So they can take up nutrients from a full metre down. So we're profiling the soil down to a metre. Now we won't have, back in Dunhill area for instance, we don't have a metre of topsoil. If we had, we'd be able to sell it to the neighbours just over the road. We've got less soil, but we're still looking at the full depth right down to the bedrock, full soil profile. We've been putting out chemical fertilizers on our soils here for decades, right? But if you look at the volumes applied of phosphorus, for instance, which is globally a very scarce product, and look at the amount of product we've been taking back from that soil, it's only a fraction of what we've been applying. So where is it all going? Is it locked up in that soil deeper down? Or is it leached? Hopefully, it's locked up in that soil. And we're looking now at a range of plant species here that can go down and do the mining, if you like, and get up those nutrients and recycle them, and bring them closer to the surface without having to go back and apply more manufactured fertilizers. And that's the direction we're taking with the research here. And do we really need to apply products like chemical nitrogen anyway? The science tells us no. If we look here way back, for years we've known that if we apply chemical nitrogen onto legumes, you don't improve the performance, you suppress the performance. And that information has been there for years. Another point that's brought up again and again and again is, can we make silage from these full clover swarts or these big species swarts? And the answer is absolutely yes, we can. And even going back to 2008, 2009, we have research from our own centres here in research centres in Ireland here, where we see livestock performance on silage over winter, just grass silage only on beef animals. We get just short of 0.6 of a kilo per day live weight gain. When we mix it with clover, white clover, we get 0.83 a kilo, and red clover swart, 1.04 of a kilo per day live weight gain. That information is there for nearly 2 decades. So why does the question come up, can we use legumes for silage? Yes, we can, of course we can, and the scientific evidence is there. This is a snap that I got from one of my students the year after they finished in college. If this is a multi-species they put in after looking at the research trials and so on, and the work that we were doing, she went back, got a really good take, really strong sword. But if you look at the area on the right-hand side, outside the fence, and then look at the area from the second tree down to the corner here on the left-hand side, the crop has done really well. But if you look at that patch in the middle, it hasn't performed quite as well as it should have. And she sent me that picture. And she was really annoyed at the time because her dad was out on some of the rest of the farm spreading chemical nitrogen on grassland. He had a little bit left in the fertilizer spreader, and he came in and just did one strip up the field. Thought, right, we'll boost this on a little bit now. And of course he got exactly the opposite result. And you can see that that crop is suppressed a little bit compared to the left and the right-hand side. You know, so again, proof if she wanted it. She didn't want it, but she was glad it happened because she was able to go back to her dad and said, now look what you've done. So look, the science is there, the evidence is there. We just need to listen to it. This is another piece of research from one of our students. And okay, on that last picture there, I'll just go back to it. This person is looking at what was happening on top. You know, but just this year earlier and last year, one of our students looked at what's happening underneath. So we measured the soil microbial activity where there was nitrogen applied and no nitrogen applied, and did it on a whole range of crops. And if you look at the activity line where the nitrogen was applied, there was much less microbial activity in those soils than where there was no nitrogen applied. Again, those fertilizers are suppressing that microbial activity. And remember, the plants produce the sugars to feed those microbes, and they in turn feed the minerals to the plants, which feed it to the cows, which feed it to the rumen microbes. So if we suppress all that activity, then the plants are going to be a little bit more deficient in those minerals. And likewise, the rumen microbes will be more deficient in those minerals. So we're, at every point, we're interfering with all that ecology from A to Z. And on those minerals, we looked at the requirements for the dairy cow. They're the blue or the green bars here. And we analysed all of these species individually and looked at the mineral profile. You know, and what you see in the blue here is a combination of those plant species, the red clover, sheep sorrel, chicory, shepherd's burnet, right? And a combination of those four, we're able to pull up and cover all of the mineral requirements for a dairy animal. You know, so again, even if those minerals are not available close to the surface, these plants in particular, they've all got deep rooting systems that can go down and they can mine from and pull off the reserves that are there. And then we're constantly feeding back a small replenishment with that small amount of slurry a couple of times a year. Right, you know, and that's kind of trying to get a picture of the whole ecology and how we can keep that efficiency there and not put a boot in to disrupt it anywhere. And that's going to help our animal welfare, our animal health. Incidentally, that herd, they had their annual TB herd test in September last year, and it came around in October this year, just 3 weeks back, and it's clear again. In between that, there was one call in for the vet, right? An animal, weaning animal that he thought might be getting pneumonia. Vet came out and had a look, checked the animal, said, no, she's fine. I think he gave her a multivitamin and closed the boot and drove off out the gate again. You know, so false alarm. So from an animal health perspective, once we take out all those chemicals out of the system, incidentally, he's not using anthelmintics either. There's no requirement to. We did some drug tests for egg counts. There's a small few, but we wouldn't be able to get anthelmintics now even through the vet because of the low counts. But because of the rotation system, some of those species have anthelmintic properties as well. We're looking into that a little bit more, trying to identify which ones are more potent. But from every viewpoint you want to take on it, you know, the impact is huge. And our dairy production systems are getting a hammering globally right now. But again, it's a concept, it's a mindset you want to put out there. If you want to cover up something, you say, that's over to your right. You pay all your attention to something on the left, get everyone looking that way, and ignore what's at this side. But if we look at our global cattle numbers, we're just over 1 billion there. Hasn't changed very much. It's changed less than about 0.8 of 1% only from 2012 to 2022. Right, and our dairy cattle are in at around 13.9% of that. Just a small percentage overall. Right, and here where we are on production, we've got just short of 140 million cows, EU about 23 million, US 10, India 58 million, and make up the others about 48 million. What are they producing? What are they giving us? Over 500 million tons of milk, 18.5 million tons of the highest quality protein that we can eat, and 22.8 million tons of fat, over 40 million tons of solids overall, of the absolute highest quality food that we can have. It's the first food that we all encounter in our lives. Right, and we've been getting hammered lately. Everyone's been shouting about the amount of methane that these animals produce. Right, but let's put things in perspective. Right, the cow eats the grass, the rumen microbes process it, the cow belches out an amount of methane and quite a lot of food product and nutrient for the soil microbes. Right, that methane has about a 12-year cycle in the atmosphere where it's broken down to CO2, carbon dioxide. What do plants need? Carbon dioxide. So the plants that the cows are eating, whether it's grass of mixed species or multi-species, that absorb the CO2, produces a lot of mass that the cows eat again. So that carbon, that methane, is recycled over a 12-year period. And if you go back to that cow that I showed you earlier, 14 years old, 10 years lactations. When you look at the full cycle over her 10 years, she's pretty much working out carbon neutral. But the concept is very different. Why? Because everybody wants to put out a message that ruminants are not the problem. Or ruminants are the problem, but they are not. They're part of the ecosystem, ever before we started interfering with it. And here's the true picture. Right? If we look at the bottom at the biogenic methane that the ruminants produce, right, on a 12-year cycle, we're pretty much flat line. They produce methane, it's broken down to CO2, it's absorbed by the plants, that the animals eat again. So it's just recycling, recycling, recycling. The top one, the fossil methane and CO2. We're producing billions of tons of CO2 every year from fossil fuels and from fertilizer production. But your car can't go out and eat grass and recycle that CO2. So it stays in the atmosphere. So where is the increase coming from? It's not coming from ruminants because their population hasn't increased over the last 12 years. But our methane has, and our CO2 has. So it doesn't take a mathematician to put 2 and 2 together there. The fossil fuel industry is blatantly throwing out a distortion as to where the problem is. And the problem is on their doorstep, not agriculture. So if you look at the greenhouse gases and the ruminant livestock numbers going back a little further, some of these figures I just took US. The red line on top, that's the livestock numbers. We're tipping in a little bit under 100,000 from 1990 up to 2022, right? The green line on the very bottom, that's the number of dairy livestock in the US from 1990 to 22. Came from close on 11 million back in 90 to nicely under 10 million at the moment. India is the blue line in the middle. They've increased a little bit over the last 30 years. But then look at the global warming gases, right? Atmospheric CO2, the grey line at the bottom, just above the US livestock numbers, gradually increasing year on year. And that curve is getting a little bit sharper in the last couple of years. Right. Go up to the next one, the atmospheric CH4, methane. Again, the middle line there, yellow, increasing but a bit sharper overall. But look at that blue line, nitrous oxide emissions. Now that's in CO2 equivalents, right? Because if we put just nitrous oxide emissions, we couldn't fit it on that chart. It's gone way off the scale. But look at where that's increased over the year. Okay, this is just going, adding in one more line. I know it's pretty crowded, but if we just concentrate on that red line across the middle, okay? This is back from 1850. Number of bison in the US in 1850. The figures I could get were somewhere between 30 and 60 million. So I just took the halfway line, 45 million. It's pretty much on the same line as the number of livestock in India. Right, that was almost 2 centuries ago. So we had ruminants roaming about a couple of centuries back. But where are our methane emissions? Where was the issue with CO2 emissions? So over the last 2 centuries, our total global ruminant numbers haven't actually changed all that much. But our atmospheric greenhouse gases have. And where's the main issue? Nitrous oxide emissions. Right, nitrous oxide as a greenhouse gas is 265 times more potent than CO2. And look at the nitrogen global sales figures. Right? The blue line there, nitrous oxide emissions from 2003 to 22. Very clear curve. Global nitrogen sales emissions. Almost parallel. If I use the exact figures there, if I average those, to be like 2 rail tracks going up along. So I don't think anyone needs any more evidence than that to see where's the problem coming from. And it's mainly from the chemical fertilizer industry. And there's the evidence. We just need not to hide it. Okay, so it's up to us going forward. Do we ignore that like we have been doing up to now? Or do we take a different route and use the scientific evidence that is there and is there for a couple of decades at least from our own researchers here in Ireland? Are we going to pay attention to that? Are we going to apply it? Are we going to use it? There. So it's back to us again. We're part of the biosphere. The animals are part of the biosphere. How do we manage that? How much attention are we going to pay to it? Are we going to take care of it? Right? And look at our ecology. We have a wonderful planet, and we have wonderful amenities. And I think one of the things maybe that's happened over the last couple of years here in Ireland in particular, with the restrictions, the movement we've had, and the lockdowns from COVID and so on, we weren't able to travel. We've had to look at what we have at home. And hundreds of thousands of people, I think, have come to appreciate more what we have at home, and the diversity we have in our own ecosystems here. Right, and ruminant livestock are a very integral and necessary part of all of that. So it's up to us to look after it. Right. Thank you.
Come back, Mike, into the middle,
Okay.
please.
Thanks.
I have
Bring this
questions.
along.
I imagine a lot of other people have a lot of questions too. Thank you very much for that. It was really, really interesting. I guess something that I have in my head is this whole debate that we have about biogenic methane, and we know it's been quite heated in Ireland, we know it's been quite heated in New Zealand as well. And when you're talking about microbes, to misquote W.B. Yeats, tread softly for you tread in my dreams, I was thinking tread softly for you tread in my microbes every time I'm going to be walking around the farm now.
Every time you wipe your boots.
No news. But I mean, so Ireland's emissions, agriculture accounts for 35% of our emissions, and 2/3 of that is meant to be from the eructation, the burping and the other equivalent out of the hind end of cattle. And this whole debate about biogenic methane. But what you're saying is the argument around biogenic methane is legitimate, but only if we take out chemical fertilizer out of the equation as well.
What I'm saying is we absolutely do not need chemical nitrogen fertilizer in the equation in the first place. And the scientific evidence is there.
How do you convince the normal conventional dairy farmer listening who is getting possibly the same yields as that?
But how much is it costing him?
Okay.
You know, and apart from the financial cost, what's the cost of the environment? Look, it is difficult because everywhere you look, every farm journal or publication or magazine is full of promotion for one product or another and another. And there's massive amounts of them from the chemical and pharmaceutical industries. You know, and it's only, like if you look at our global emissions, it's only when we started to use those back to the 70s when we started to use them intensively, or a little bit further back, mainly after the First World War. And at that time we did have food shortages, food scarcity. And it was seen at that time as a quick fix, you know, but a quick fix is seldom good in the long term.
Yeah.
And, you know, I think once commercialization got into it and marketing, then it just snowballed. Okay. So we need to just come back to, you know, letting nature do what it does, provide food right across the board. You know, and it's not going to mean you're going to lose production. You know, if you take the right approach, we're not saying that anybody should just change over from what they're doing today onto a totally different system tomorrow. You know, that's not going to work either, that kind of quick fix.
And there is someone going around with a roving microphone if anyone has any questions, but Kevin O'Hanlon has sent in a question online, and he's saying, would a more diverse mix last longer in regenerative approach to grazing in a dairy system? So I guess that's this whole thing of how long are swards lasting, essentially.
In terms of
years, in terms of, I guess, multi-species swards, and then the rotation that he's using. So he's talking about a 21 to 28 day rotation that he has his cattle on.
If we start where we are today, we have different growing, you know, the pastures grow at different rates throughout the season. You know, we'll have fairly rapid growth in the springtime, March, April. Once we get into May, then grasses tend to want to reproduce, they want to head out. So the whole nutritional profile of those same grasses changes, but we don't adjust our diets, you know, to match that. And it's the same with multi-species. Again, as the season moves on, like I said, in what we're doing there, just with those mixes that we've been using for 25 odd years, in wintertime, late season and early spring, we have quite a lot of grass there. You'll see maybe 50% grass, 50% clover, but as we get into the summer, the clovers just take over. You know, so there's change as we go along in the seasons. This year, even on dry soils, they just kept coming because with a lot of deep-rooting plants there, and the moisture stress didn't really affect them that much. We always supplement a little bit of forage the whole year anyway. We didn't have to increase it very much this summer.
Does anyone have any questions from the floor? I see.
Sorry, maybe just one thing in terms of multi-species and what do you put on your farm? Yeah. You know, how much diversity do you put in there? And the approach we've taken is we'll always go for a lot of diversity. We'd have 13, 14, 15 different species in the mix. You know, and what we're finding over time, depending on the management, the soil, the environment, the intensity, we'll probably lose 3 or 4 or 5 of those species over a couple of years. But you still got a hugely diverse swart left. And we're finding that we get in a couple of invaders, and say, what would normally be classed as weeds, you know, and one of the guys this year put in a mix, and he got a lot of, we'll call it for now an invasive weed. Most farmers will be familiar with it as fat hen, right? Quite a big strong weed. And he said, what am I going to do about this? And I said, well, see what will they do with it. You know, I let the cows into the sward for the first time. The first couple of hours, it was gone. And when we started looking into the science, we've discovered that it's one of the plants that actually has quite strong anthelmintic properties. You know, we've got dandelion in there, again, which I'd welcome in. No, so I wouldn't, I think putting in enough of a mixture of species day one, and then your management is going to do the selection, and your soil type, and those microbes underneath. Do they get on with them?
Will we take that question from the floor?
Yeah.
Mike.
Could you just introduce yourself as well with your name? Would that be all right? Could you just introduce yourself as well?
My name is Christopher Cook. Mike, I really appreciated your presentation. It was beautifully done and very informative. The one area I'd like you to comment on, please, is around mastitis. You haven't spoken about that so far in the presentation. And for me, it's a significant cost, both financial, hassle factor, and animal health. And I wonder if you'd comment.
Yeah, so just a question, just in case anyone didn't hear it because the mic wasn't working very well. So it's on mastitis. So I guess maybe perhaps in the trial.
I'll go back to our case study herd, if we call it that. Again, haven't used any antibiotics for over 2 years because we're introducing a feed product from a Dutch company as a bolus for any mastitis cases that have occurred, and there haven't been very many occurring, you know, and I think you saw the average lactation number of the herd are 6, you know, so any cow that does appear with a problem, we don't see any point in holding on to those genetics. There's something probably wrong in the background there, so she's moved on, but we don't get very many. But again, using that feed additive, it's not a real issue. I think the average cell count there for this month so far was the highest reading they got on the collection, on the bulk collection, was 130,000, but generally it's been under 100. You know, but again, it's looking after the animal, let the animal's own immune system look after them, and it does. And once you're not interfering with the whole metabolism, then they can do that.
We have any other questions from the floor? There's one or two more, and there's one online as well.
Thank you. Douglas Gordon. I'm not a farmer. I run a company called Quest Utility Services. We're specialists in revitalized water. In the various different presentations, I understand the angle at which they were promoted in terms of microbiological health, but there's little discussion about water. And what we're doing is we're adding an imprint of the magnetic field where the microbes respond to that. In this case, and in the ruminant system, they are positive. They actually optimize the animal. And not only that, but if the ruminant animal is a processor of cellulose, in some cases concentrates, whatever comes out the rear end, that's pre-processed, and it's going into, in the case of cattle, a slurry tank. But we have another device based on water that goes into the slurry tank, and that optimizes the slurry. So it's a pH neutral slurry, and when it's spread on the land, it stimulates the soil structure as well. So you have in the rumen.
Do you have a question? Because we
Well,
are just running out of time.
I'm coming to that in a second. Just I understand that. We can suppress the synthesis of methogenic bacteria to achieve a reduction of 30%. I understand your angle, but I'm just saying there's the. But then we also sequester carbon in the soil structure. Thank you. And I'm just trying to find out whether water is being researched at all.
Well, the animals need water the whole time, but we use natural spring. We use rainwater collection, but there's no water treatment. And again, we go back to the number of lactations, the average number of lactations we're achieving on the herd, which is, I think, just about double the norm. So we're pretty happy with what we're doing at the moment.
Yeah, I think we'll take one last question just online, and it's in regards to any specialised form of composts. Are they being used on the farm? Any compost teas, anything like that?
No, to be honest, there's, any waste you might get on top of the silage pit when you roll back the plastic, particularly at the margins, just at the very edges, we just take that off. If you spot a little bit of mould or anything like that in there, we don't allow that into the rumen. So that'll be as much waste or compost as we have, and there's some bedding for some of the calving cows and so on. That's put out on the surface just coming up before winter, and the earthworms and everything have plenty of opportunity to process it in over the winter. And that's pretty much it. So composting, we don't actually have enough material to do much composting. Everything is recycled very quickly. And you saw even, I was trying to demonstrate there with the, when we took the maize off, that was taken off on Friday. The new seeds were in the ground on Saturday. Okay. If we had something available in the yard at that time, that would have been spread on that and just very lightly brushed in. We only just loosen the soil on the surface enough so that the seed has contact with the soil.
Yeah.
That's all, but we try to avoid disturbance of what's under there. Those microbes are happy out there, let them party.
That's a good point of wisdom to finish on. Everyone, thank you very much. Mike, thank you very much for that. That was brilliant.